Hey guys, in this video I'm going to do a quick introduction into iron absorption and what could go wrong. Enjoy. The primary sources of iron in our food are meat, egg, and leafy greens like spinach and collard greens. So after we've consumed our iron in our food, it gets broken down into its component products, and it's important that it gets properly broken down in the stomach because the later absorption requires for it to be accessible and soluble. So all of that is done in the stomach, and any damage to the stomach or any surgeries such as gastrectomy could limit the later absorption of iron. In the case of heme iron, which is just like the hemoglobin in our blood, when we consume it in the form of meat from animals, it gets absorbed more easily than other forms of iron, and at first it gets absorbed through a specific heme transporter into the enterocytes or small intestines, and inside the enterocyte it will react with heme oxygenase 2 to free the iron from its porphyrin ring, so that now it's just iron 2, and from here it can be either stored with ferritin to prevent it from building up in the cell and causing damage, or it can be directly ferried out of the cell through the use of an enzyme called ferroportin, which has part of its an associated enzyme, hephaestin, and hephaestin allows the iron 2 to be transformed into iron 3 so that it can be transported into the blood and bind to transferrin so that it can be transported around the body. In the case of non-heme iron, however, which is more common than heme iron, the divalent middle transporter 1 is the enzyme transporter that will bring the iron into the cell. But before that can happen, it has to be reduced by surface reductases from iron 3 to iron 2, and once it's in this form, the divalent middle transporter 1 will transport it into the cell, where it can directly bind to ferritin to be stored, or again be transported by the ferroportin hephaestus combination. Hephaestus, of course, will again turn this iron back into iron 3 so that it can be absorbed into the plasma and transferred around the body by transferrin. In general, enterocytes only last about 3 to 5 days, so any iron that's been stored up in the ferritin slows off in the small intestines and goes off with the stool to be released from the body. When there's a lot of iron, for instance, because of lysis of red blood cells, so if there's an iron overload in the system, another enzyme comes into play, and this enzyme is called hepcidin. It's produced by the liver, and this enzyme controls or regulates the transporters ferroportin and hephaestin, and by decreasing the amount of hephaestin and ferroportin, that will increase the amount of iron that ends up being stored inside of the cells. So if there's more iron being stored inside of the cells instead of being transported out, because there's no way for it to get out into the bloodstream, when the enterocyte as a whole is slowed off, when the whole enterocyte is slowed off in the stool, all of the iron that's inside of it will go along with it. In the opposite situation, where there are low amounts of iron in the bloodstream, the liver will actually decrease its secretion of hepcidin, and without hepcidin, each of the enterocytes will have its own transporter, and all of the iron that's stored up will be transported into the bloodstream.